quantity that does not have an associated direction, like the time it takes to do something, or the amount of energy required to complete an action. So to recap, they have a numerical value. They do not have a direction, and some examples can include time, speed, or temperature. Vectors, on the other hand, are values that only describe fully with both a magnitude and a direction. They must have both. Some examples of vectors are velocity, acceleration, and force. Scalars are useful in normal conversations. For example, how long were you gone for? How far was your trip? However, in order to be more specific in certain cases, vectors must be used. A good example is the difference between velocity and speed. Speed describes the rate at which an action is completed. On the other hand, velocity describes the rate at which actions are completed in a certain direction. For example, the speed of a car heading west may be described as 45 kilometers per hour. However, its velocity would then be described as 45 kilometers per hour in the direction west. As you can see, the velocity has the added direction component. Next, we'll go over some basic problems in order to reinforce this concept. A man walks 7 kilometers in 2 hours, and then 2 kilometers in 1 hour, in the same direction. So, part A of this question is asking, what is a man's average speed for a whole journey? And part B is asking, what is a man's average velocity for the whole journey? Part A, so we can use the formula speed multiplied by time is equal to distance, or st equals to d. And isolating for s, we'll get d over t, and the value of d is equal to 7 kilometers, so 2 kilometers, resulting in 9 kilometers. And the value of t is equal to 2 hours plus 1 hour, resulting in 3 hours. So therefore, the average speed of the man is 3 kilometers per hour. Pretty straightforward. Part B, okay. What is a man's average velocity for the whole journey? Here the answer will be the same as part A, except now we need to add a direction to describe the vector, or rather the magnitude will be the same. We can describe this through the use of square brackets, in which we'll write our direction of travel. So the man will go forward, for example. So the displacement, we're going to use the formula velocity multiplied by time equal to displacement. The displacement would be 7 kilometers forward plus 2 kilometers forward, and resulting in 9 kilometers forward. Since time remains the same at 3 hours, the resulting velocity average of the man is 3 kilometers per hour forward. Okay, next question. A man walks 7.0 kilometers east in 2.0 hours, and then 2.5 kilometers west in 1.0 hours. Okay, the first part of this question is asking, what is a man's average speed for the whole journey? Part B is asking, what is a man's average velocity for the whole journey? Okay, let's start with part A. So again, we can take the total distance traveled and divide it by the total time spent to do the traveling. It results in the average speed of a man being 3.2 kilometers per hour. However, for part B, it's a little bit different. Again, we use the formula velocity multiplied by time is equal to displacement, or Vt equals d, and isolate for v, giving d over t. Here's where it gets a little bit tricky. We must make the distinction of velocity to speed. Whereas average speed is calculated by total distance divided by the total time, average velocity is calculated through total displacement divided by total time. Displacement is in fact the vector form of distance traveled, also known as position. When we use displacement, there is a magnitude as well as a direction of travel. Instead of the total distance traveled, we look for the straight line distance between the 2 points of measurement. In this case, the total distance traveled will be 7 kilometers plus 2.5 kilometers, or 9.5 kilometers. However, the straight line distance would be much different. Because we walk in one direction for 7 kilometers, but turn abruptly around 180 degrees, and then head the other direction 2.5 kilometers. We decrease our distance from the origin point. This can be calculated by simply adding the two values together. We write that the displacement is equal to 7 kilometers east plus 2.5 kilometers west. Or we say it's 7 kilometers east subtracting 2.5 kilometers east, because east is the opposite direction of west, resulting in 4.5 kilometers east. Since time remains the same, we use the same formula again. V equals to 4.5 kilometers east divided by 3 hours. kilometers per hour east. So hopefully these examples were useful for you to learn the concepts of magnitude and vectors, as well as the difference between speed and velocity.